Hello everyone. So today let's solve the problem 152 maximum product subarray, right? So let's see what the question states here. So we are given an integer array nums, right? So you can clearly see here integer array nums, which consists of the integers. We have to find the subarray. When I hover the subarray, what is subarray? A subarray is a contiguous non-empty sequence of the elements within the array. So we have to consider contiguously, meaning continually 2, 3, minus 2, 4. We cannot consider just 2 and then we can hop into minus 2. No, we cannot just consider this one 2 and then hop into 4. No, we have to consider 2 first, followed by 3, then only minus 2, then only 4. We have to, that is the subarray they have given here definition, right? If I hover over here, the subarray is the contiguous non-empty sequence of the elements within the array, right? So within an array. So given an integer array nums, we have to find the subarray that has the largest product, and finally we have to return the product, right? Again, let me tell you this one. Given an integer array nums, what we need to find? We need to find the subarray that has the largest product, right? That has the largest product, and we have to return the that product itself we have to return. And they have mentioned that the test cases are generated so that the answer will fit in a 32-bit integer. This is fine, man. Yeah. Now let's move on with the example one. Yep, let's move on with the example one here. So here we have the nums 2, 3, this one minus 2 and 4, right? So 2, 3, we have to consider continually, right? So 2 into 3 is 6. If we consider 6 into minus 2, then it will be this one, what do we call, minus 12, minus 12 into 4. So this will be 48, minus 48, quite obviously. So we'll be getting this one in the negative basically, right? So we have to consider continually, they have strictly mentioned. So we have to go with the 2 into 3. 2 into 3, so this gives us in the positive. So 2, if we consider only single digit, this will be 2 or this will be 3. So it's better to go with the 2 into 3, so which is quite obviously 6, right? 6 is the output that we need to get. See, the output that we got here is 6, which is equivalent to the output they have given here. This is fine. So 2 into 3 has the largest product, 6 here. That's what we need to find. So let's move on with the second example here. We have minus 2, 0, and minus 1. So one thing we need to know here is we have to select two numbers for the multiplication. Two numbers for the multiplication. And also they have mentioned in the question that at any cost we have to consider continually the subarray, right? Subarray is nothing but we have to consider the elements continually or contiguous one, right? So here we have to multiply 0 at any cost by minus 2. So minus 2 into 0, anything multiplied by 0 is quite obviously 0. We know this one, right? So this is fine. Now, uh, whatever we multiply by, so this will lead to 0 itself. We have only one number that is multiplied by 0 will be 0. So 0 is the output that we need to return here in this case, right? This is fine, I believe. Easy one. The result cannot be 2 because minus 2 into minus 1 is not a subarray. Yeah, we as I've said earlier, this one itself, earlier itself, we cannot consider, we cannot skip the elements, right? So we have to consider this one continually. So we cannot just consider minus 2 and minus 1. We have to consider this one and then go to the minus 1, right? So here, yeah, so the output will be quite obviously 0. Anything that is multiplied by 0 is 0, right? So the output will be 0, right? So yeah, they have given us wonderful examples just for the sake of understanding. Now let's do one thing. Before getting into the approach part, let me tell you one thing. So that we will be going with a DP, dynamic programming, to solve this particular problem, right? So we will be going with the dynamic programming to solve this particular problem, right? So we'll be going with a 1D DP, man. So we will be going with 1D DP, or so we'll be going with the dynamic programming to solve this particular problem. Now this is fine. Now let's move on with the approach. So here, example, the first example we have considered for the approach. So here we will be initializing two DP arrays. See here, one is max prod and another one is min prod. This is nothing but the maximum product of I and the minimum product of I, right? Simplified form, just for the sake of naming the variables. Yeah, this is fine. Now, maximum product of I, this stores the maximum product ending at the index I. This is fine. Maximum product of I, what this variable does, it stores the maximum product ending at the index I, and minimum product I stores the minimum product that is ending at the index I, right? This is needed for the negative into negative. Negative into negative will give us the positive value, right? So this is very important, right? So that is the reason we have considered max and min prod. This one variables, max product of I and the min product of I, whatever I have considered. So for each number, maximum product of I is max of nums of I comma nums of I into max product of this one I minus one, the previous one comma nums of I into same thing min product of I minus one. The same goes with the min product. So here instead of the max, we will be going with a min. We will be finding the minimum value, right? This remains same actually. This remains same actually. This remains same, but we will be finding minimum instead of the maximum, right? So this is fine. Now we will keep track of the global maximum product that is seen so far. So that's what we will be doing. So now let's implement the same thing to the example one that they have given in the question, right? So first step here, I0 we have, max also we have, max and min we have 2 here. I we have been given 0, max and min we have 2, and the global max variable we have been given 2, right? So I 0. So this one, max we have been given 2, min we have been given 2, and global max we have been given 2 as well, right? Initially, we'll consider global max as 2 itself, max 2, min 2, and global max 2. So when for the first iteration, when I equals 1, max equals the same thing. So here this formula kind of thing we'll be going with, right? So max of nums of I comma nums of I into max this one product of I minus 1, comma this one nums of I into min product of I minus 1. This formula will be going with, right? So this is fine. Yeah. Now we have when we give here min of the values basically 3 comma 32 comma 32 we get. So uh, sorry, this one basically max of 3 32 32. So 1 second. So yeah, we are going with the product, right? So here this one, max of this one, 3, 32 and 32, we have to go with 6, and min, this one is nothing but the 3. Global max, we have set this one to 6 because we have got 6 here, right? So for the iteration, second iteration, same thing. The same thing we'll be going with. Again, we'll be getting the 6, and this one here we'll be getting the negative minus 12. So global max remains same, the 6. And the third one is for the iteration 3, max we will get 24 here, this one, and the min we get minus 48. Global max we will be updating this one with a 24. So the final output will be going with a 6 basically. The final output will keep track of the global maximum, this one product that we have seen so far, right? Max remains 24, and the output that we have got is 6, right? For this one. So basically we'll be going with a this one subarray, which gives the positive value, right? So this one we get negative actually. So that is the reason we ignore this one. So see here 6, this one actually 6 into 4 24, but we cannot skip this one, right? So we cannot skip this one minus 2 here. If we skip minus 2, we get the we can just return 24 here. It's the same thing how we got 6 here. So we will be getting basically when we consider 330 to 32, right? So here, so we have to go with 2 into 3, then 6 into minus 2, again it will lead to negative. So this one is 6 and global max 24. This one we have considered 2 3 and 4. We cannot consider this one because so the subarray, it will not go with a subarray, this one definition, right? So we cannot consider, we have to consider continually or contiguously. Yep. So that is the reason the final output that we got here is 6, right? So which is equivalent to the output that they have shown for the example one within the question. So our approach works absolutely correct here. So now as we are this one completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? So the time complexity would lead to big of n here. The time complexity would lead to big of n because we'll be going with a single pass through the array. And what would be the space complexity here? The space complexity would lead to big of 1 because only 3 variables are being used, right? So we'll be making use of only 3 variables and no extra arrays. So this will lead to the time complexity would lead to big of n, and the space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively. Now, as we are completely familiar with the approach and the complexities, let's do one thing. Let's start writing the code, right? So here, the first step would be what we'll be doing here. So let's assign n to nums dot length. So we'll be making use of the length of the nums everywhere. So let's assign this one to the variable n. Now, as we had discussed in the approach, let's go with a global maximum product. Let's go with a minimum product ending at the current index, and let's go with a maximum product ending at the current index. So this one will be max product. So this one, let me assign this one to the first index nums of 0. Also int. So this one minimum product. I'll just go with, as we'll be making use of the 1D DP, I'll just go with the min DP here. So this one will be nums of 0. And also, so let me go with here capital P. Right? So this is fine. So let me keep this one min product. Again, I have to type this one long everywhere. So this is fine. So this one will be max product or max DP. Let me assign this one to the nums of 0 as well. Yeah, next let's move on with the iteration part. So this one will be for int I equals 1, I less than n, I plus plus. So within the for loop, the first step is int current equals, uh, we'll be assigning this one to the iterated value of the nums. This is fine. So we have to store the previous max DP before updating, right? So let's make use of the temporary variable naming temp max here. This one, let me assign this one to the max DP. Yeah, this is fine. The next step here would be, let's go with the min DP as well as the max DP, right? So as per this one, what do we call? As we had discussed the same within the approach. So we'll be going with a max product that is ending at I, and we'll be going with a min product that is ending at the I. Let's go with a max DP. It is equivalent to the mat dot max of, so this one will be current, comma, mat dot max of this one current into max dp, comma, current into, so min dp. This is fine. Yeah. Now let's go with the min dp. So this one is mat dot min of. So this one will be current, comma, mat dot min current into. So this one will be temp max current into min dp. This is fine. So we have to update the global max as well. So for this one, I'll just go with max prod that is equivalent to mat dot max of this one max prod along with a max dp. So this is fine. Finally, what we need to do here, so we have to return the largest product that is found, nothing but max prod. So I'll just go with a max prod, right? So this is fine, man. Yeah, let me format the code once and let me hit the run button. So here, cannot find the symbol min dp. So yeah, let me make this one capital P. Yeah, let me run this one again. So again, this one has to be capital P. Now let me hit the submit button directly, as we had only one error. So I can clearly see here all the test cases are getting passed. So whatever the code that we have written works absolutely correct for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.